So the first few videos we looked at writing the known alternative, and then we went through the procedures of how to get our numbers to actually analyze them, the critical value and the test statistic. Well, now we're going to go through two examples, okay? So every time you're going through these, okay, we have write your known alternative hypothesis. That's your first step. That's going to be the statements that we're going to be judging. Okay, draw your curve and use the chart to find the critical value. Okay, so again, this is the critical value method. So we have our curve. You should have your T-chart in front of you. And now we're on calculate the test statistics. You need your sample average, sample standard deviation, sample size, and then the value of our mu, what we believe the population average is going to be. We have that out. Now we can compare our numbers and write out our conclusion. Okay, so right there is your 4 steps. Okay, so follow these steps, and you should be able to complete a hypothesis test. E-Town claims that they forget less than 12 kids on field trips each year on average. Below is a list of kids forgotten each of the last 10 years. Test the E-Town claim with confidence of 99%. Okay, so again, with the conditions, we're assuming they're satisfied. We're assuming a normal distribution, randomness, as random as we can be, and now we're going to go ahead and calculate and run our hypothesis. The first thing you need to do is write your known alternative. Okay, so it says E-Town forgets less than 12 kids. So we're judging the claim of E-Town, saying they forget less than 12 kids. So if I'm writing this out, we have our null, mu equals 12 kids. Okay, remember the null is always equal to, and it says less than 12 kids, so our alternative, less than 12 kids. So there's our known alternative. There's step 1. Okay, so we're already working our way down. Okay. Next, we need to find our critical value. Okay, so I'm going to draw the curve over here. Let's remember we look at our alternative to know if it's a left tail, right tail, or two tail test. We have a less than, so that means it's going to be a left tail test. And we're going to have the reject and fail to reject areas. Okay. Now we need to find the critical value to put there. Here's our curve, and now we need to find the value there to know what that line represents. Okay? So this is where now we're going to go to our curve. First, you're going to need your degrees of freedom. Okay, so right over here, degrees of freedom, n minus 1. Okay, we have our sample size of 10, so that means 10 minus 1. Degrees of freedom equals 9. Okay, so if we go to our chart, think about what you need. One tail, degrees of freedom, and our confidence level is 99%. So looking at the chart now to find our critical value, okay, we have to remember one tail, degrees of freedom is 9, and we are being 99% confident. So if I'm looking at this, highlight my pen, there's the one-tailed, 99%, so that means our alpha would be 0.01, and degrees of freedom is at 9. So I'm just circling all the information. Now if you just zero in, going down here, our critical value would be 2.821. Okay, now all the values on here are positive. Since we are a left tail test, that means it would be negative 2.821. Negative 2.821. All right, so now we have our null alternative, we have our critical value. Now we need to find our test statistic. Our test statistic is sample average minus mu divided by standard deviation divided by square root of n. Now since it's giving us a data set, I would want to plug this in my calculator and use one variable statistics to get our sample average, sample standard deviation, and our sample size. Okay, so if you want to pause and do that on your own, and let's make sure our numbers match up. I have our average being 11.7, standard deviation being 2.983, and our sample size being 10. Okay? The mu symbol, that's coming from our null over here. Okay, so that's coming from over there. So they're the 4 pieces that we need. So if I take all this and plug it in, 11.7 minus 12 divided by 2.983 divided by square root of 10. Now make sure you're doing square root of 10. Sometimes kids will put 9 in there, students, because of its degrees of freedom. That is our n, so it's square root of 10. Don't do the minus 1. And also remember, if you're going to plug this on at one time, make sure you put in parentheses around that top part and the bottom, the numerator and denominator, so you can plug it on at once. Our test stat ends up being negative 0.318. Negative 0.318. Now what you need to keep in mind here is, if you plugged it all in at one time, or if you did the numerator, then the denominator, did your division, the way you're rounding, it might be a little different. So if you have negative 0.317, negative 0.32, something around that negative 3.18, most likely you typed everything incorrectly. It'd be a very big coincidence if you made a mistake and you got an answer as close as ours. Okay, so that is our test stat. I'm gonna label it as test stat. And this is what we're using with our curve to determine if we're going to reject or fail to reject. So if I'm looking at this, negative 0.318, this is just like a number line. So if we had negative 2.821, negative 0.318, it would be on the right-hand side, somewhere over here. I'm not 100% sure where, I'm not gonna measure it out. I just know it's on that fail to reject side. So I know our answer is fail to reject. Okay, so here's our steps. We did our null and alternative. We drew our curve and found our critical value using the chart. Went through our steps, average, standard deviation, and n using one variable stat. Plugged everything into our formula to get the negative 0.318 as our test stat. And plugged it in and looked at the curve and decided we failed to reject. Now, we're deciding to fail to reject a null. What does that mean? Because your conclusion needs to now explain in context what our decision should be. So if I'm looking at this, I know I failed to reject. I'm going to erase all this. Once you decide if you reject or fail to reject, okay, we decide to fail to reject. So that means we fail to reject the null, means we support the null. Okay, so we're saying that there's not enough evidence to go with the alternative, which was less than 12 kids. E-Town forgets less than 12 kids on field trips. So how I would write this out, we would fail to reject the null, so we support the null. We do not have evidence to say that E-Town forgets less than 12 students a year. Okay, so we're siding with the null. The null alternative, okay, the alternative was the average is less than 12 kids. We have no evidence to say that. Since we fail to reject the null, we're saying that it probably is equal to 12, possibly could be more than 12, but there's no evidence to say it's less than 12. So the claim for E-Town is incorrect. Okay? So take a second, jot this down and make sure you have it in your notes. Use this as a template to think, what does it mean? If I fail to reject, that means I support the null, and think about what the null is. Think about what the null means in context. Okay, let's do one more example real quick, probably move a little faster through this next one. Okay, so again, we wrote our null and alternative hypothesis. You draw your curve, use the chart to find the critical value, calculate the test stat, might need to use one variable stat to get those pieces, and you compare and write the conclusion. Rolling Stones magazine claims that lead singers in metal bands burn at least 1,000 calories during his show. For a sample of 13 shows, the lead singer burned an average of 892 calories with a standard deviation of 145 calories. Is Rolling Stones claim true at 95%? Okay, so now we're looking at burning calories, and this says at least 1,000 calories. So I have null, mu equal to 1,000 calories. mu is greater than 1,000 calories. Okay, so there's our known alternative. Okay, this is the claim that it burns more than 1,000 calories. If I'm drawing my curve, right, this time, since it's greater than, this is going to be a right tail test. So there's our critical value. And again, we have the reject in the tail and fail to reject. Okay. So the pieces we need: one tail, we have a sample of 13, and we're going at 95%. So think about what your degrees of freedom is, think about what the tail is, okay? Then go to your chart. So now we're looking at a right tail, one tail test. We have our degrees of freedom is 12, and we are 95% confident. So go in my pen again. We are at one tail, 95%, so we're looking at 0.05 alpha level. Degrees of freedom was 12, so we have to go down to this part of our graph. And if we're following all that, we should have 1.782 as our critical value. And this time, since it's right tail, it's going to be a positive 1.782. Okay, so there's my critical value. It's positive because it's to the right. Okay. And now this time, when I'm finding my test stat, okay, we have all the information in here. Okay, it gives us a summary statistics in here, the average of 892. So we have average equals 892, standard deviation is 145, and our N is 13. Okay, so if we plug all that in, 892 minus 1,000 divided by 145 divided by square root of 13. Okay, think about where your parentheses go. And I have, if I do that calculation, negative 2.686. Oh, sorry. Negative 2.686. So now I'm going back to my chart. Where does that negative 2.686 land? Just like a normal number line. 1.782, so negative 2.686 would fall again in the reject area. I'm not concerned about how far over it is. I just care about what area it falls into. And now we decided that it's failed to reject. So again, think about what does that mean to our conclusion. If we fail to reject, we're saying that the null is true. There's no evidence to show that it is over 1,000 calories. Okay, there's no evidence to say that a lead singer burns more than 1,000 calories. Okay, we are failing to reject the null, which means we side with the null. The Rolling Stone is not correct. There is no evidence to say lead singers burn at least 1,000 calories. Okay, so go ahead and use these examples, get them in your notes, and look over them one more time to see and remember the steps of running a hypothesis test. This is critical value method for a mean.